All right. So, to make sure we have enough time for our lab, class ends at 11:26, so I want to set a timer. We're 11:06, so I need to set a timer for today. It's just Thursday. We'll go 10:40. All right. So at 10:40, we're going to hit a hard stop. Whatever we don't get to, we're going to have to do for homework. All right. So where's my marker at? Where's my Sharpie at? Here's a Sharpie. Come on, Sharpie. Let's look at number one. Number one is a clear combustion equation. It's a clear combustion equation. Why? Because it has carbon, it has hydrogen, it has oxygen. We talked about this last time. There are 6 equations that we're going to be able to just eye a formula and know what type of equation it is. Number one is going to be combustion. One of the easier ones. C3H8 plus, I don't know why I'm here talking right now, I rewrote my equation. Now remember, how we said we want to tackle this is that we want to count all the atoms on my reactant side have to be on my product side. So under my arrow, I'm going to look for all my atoms. I got a carbon, I got a hydrogen, I got an oxygen. I got a carbon, I got a hydrogen, I got an oxygen. So under my arrow, C, H, and O. Got 3 carbons on one side. I got 1 over here. So how am I going to fix that? Add a 3. So 3. So I have my coefficient of 3. 3 times 1 carbon gives me 3 carbons. I'm going to jump to hydrogen next because the hydrogens are clearly, there's a big difference in them. And there's only 1 group of hydrogen I have to worry about. I have 8 hydrogens on one side, 2 on this side. What can I put in front of, what coefficient can I put in front of water to get 8 hydrogens? Number 4. 4 times 2 hydrogens gives me 8 hydrogens. Now, I have 2 spots of oxygen. 3 times 2 oxygen gives me 6 oxygen. Plus 4 times 1 oxygen gives me how many oxygens? 4 as well. So I have a total of 10 oxygens on one side. Do I have oxygens here in carbon dioxide? Guys, do I have oxygen in water? Remember, I'm counting all the atoms in my product. All the oxygen atoms have to add up to how many oxygen atoms I have on my other side. So I have to count for all of them. 3 times 2 oxygens gives me 6 oxygens. 4 times 1 oxygen gives me 4 oxygens. There's a plus sign here. I add them together. That means I have 10 oxygens on my product side. I currently have 2 oxygens on my reactant side. What, excuse me, what coefficient am I going to put in front of O2 so I have 10 oxygens on my reactant side? 5. With that, my equation is balanced. I feel like Thanos. Everything is balanced, as it should be.
Y'all see the new trailer for the...
Oh, can't hold it. Give me a quick sec. Everything is balanced, as it should be.
the little knife he gave to...
Like the little knife he gives to Gamora. So that means that my final answer is C3H8 plus, guys, O2 will react to form 3 carbon dioxide molecules plus 4 water molecules. That's my final answer. While a combustion reaction always has carbon, hydrogen, and oxygen, number 2 is a clear example of a double replacement equation. We are going to see this pattern play out over and over and over again. AB plus CD will react to form BC plus AD. There's a couple of things that we're going to see. These are always ionic and our cation and anion are going to trade dancing partners. A will always go with D. Why? Because A is positive and D is negative. Because in an ionic compound, you always write the cation first, followed by the anion. B will always go with C. Why? Because C is positive and B is negative. This is the pattern we're going to see over and over and over again. Our example is aluminum sulfite plus sodium hydroxide will yield sodium sulfite. Guys, this is on you. Here's my equation. Now, I could, in theory, for each one, count all the atoms. All the sulfur atoms, all the oxygen atoms, all the hydrogen atoms, all the sodium atoms, aluminum atoms. But one thing I notice, SO3, that's a polyatomic ion. That acts as one thing, yes? My OH group here, hydroxide unit, acts as one thing, right? Because I see SO3, SO3, I don't have to break those up. Because I see OH group, I don't have to break those up. I can count them as their whole thing. So instead of having 1, 2, 3, 4, 5 different atoms to worry about, I could simply just use my polyatomic ions. Aluminum, sulfite, sodium, hydroxide. And count them as I go. Where do we want to start? Do we want to start with the aluminum? Do we want to start with the sulfite? Do we want to start with the sodium? Or do we want to start with the hydroxide? Sulfite? Let's do sulfite. I got a request for sulfite. I have 3 sulfites right here in my reactant side, and I have 1 sulfite on my product side. What am I going to put in front? What coefficient am I going to put in front of sodium sulfite? 3. 3 times 1 sulfite gives me 3 sulfites.
Wait, why is it just Why is it just 3? It's one other thing. Yeah, because 3 is
That's what I'm counting my atoms. Ladies and gentlemen, with this AO3 up here, I have an aluminum surrounded by one SO3 unit, followed by another SO3 unit, followed by another SO3 unit. That's why there's 3 there. Now, if I was counting the individual atoms, then it would be 3, it'd be 1 times 3 gives me 3 sulfur. 3 times 3 oxygens gives me 9 oxygens, if I counted them individually. But because the sulfite is in my reactant and in my product, that means it's moving as one thing. I don't have to break it down by each atom. I can break it down by the polyatomic ion. I'm saving us steps. We have not talked about this, so I expected a little bit of fight on this. I now have 3 times 2 sodiums. That gives me 6 sodiums. What am I going to put in front of the NaOH so I have 6 sodiums on this side? 6. I now have 6 times 1 hydroxide on my reactant side. I currently have 3 hydroxide groups in my product side. What am I going to put, what coefficient will I use in front of it? 2. 2 times 3 hydroxide gives me 6 hydroxide.
So we just leave Al2 as it is.
We're going to find out. First, put 2 right here. Because I have 3 hydroxide groups, right? I want 6. Thank you. All right, press. I have 2 aluminum groups. How many aluminums do I have over here? 2. Is my reaction balanced?
Yeah. This is fine. I like this.
Balancing equations. So my final answer for number 2 is Al2 parentheses SO3 3 plus 6 NaOH yields 3 sodium sulfite, I'm running out of space, plus 2 aluminum hydroxide. Sir. After Brissa. So this is my double replacement. We're going to see 6 individual, we're going to look at 6 different types of reactions. These are the first 2 that we're going to look at. The reason why we focus today on double replacement is because in the lab that we're going to do today, we are going to do some double replacement experiments. Let me find another double replacement for us. Let's look at 14 together. Now, you probably didn't get the 14 yet. Silver nitrate plus magnesium chloride reacts to yield silver chloride plus magnesium nitrate. Now here I have A, B plus CD. Give me a second. Created AD plus CB. This is my double replacement. A is silver, B is nitrate. C is magnesium, D is chloride. As I see, A and D reacted with each other. C and B reacted with each other.
Wait, so
Do we see the pattern?
yeah, I have a question. Why would you not put the AQ or the S?
Well, it's because so the AQ means aqueous and the SS means solid, not something that's important for when I'm balancing the equation.
Oh, okay.
That just tells me the state of matter that's in.
Oh,
But do we see the pattern here?
yeah.
So let me rewrite it. Bless you. No, not ALAGCL.
Why ALG?
Because it's AG.
No,
No, AG. Oh, sorry. About to scribble that out. I was doing the same thing. I was making silver aluminum, guys. I do apologize about that.
really?
So if you look up here, I accidentally put an A next to L because we were working with aluminum beforehand, and it's just
Oh,
a habit. So then plus magnesium nitrate. Okay. So because my nitrate stays together, my chlorine acts as its own, I could then draw the same thing before. AgNO3 MgCl. Now, the one that changes the most that I start off with is my nitrate. I have one nitrate in my reactant side. I have two nitrates in my product side. How can I fix this? Where am I going to put a coefficient? Yeah, for the silver nitrate, right? What coefficient am I going to place here? 2. So now I have 2 times 1 nitrate gives me 2 nitrates. I have 1 chlorine over here. I have 2 chlorines on my reactant side. What can I put in front? Where can I place a coefficient so I have 2 chlorines on my product side? Next to my silver chloride. What coefficient am I going to put here? A 2. 2 times 1 chlorine gives me 2 chlorine. Now I check my other ones. 2 times 1 silver gives me 2 silver. 2 times 1 silver gives me how many silvers? Zaire. 2 times 1 silver gives me how many zeros?
2 times 1 silver?
Yes.
2.
That's all it is. Thank you, sir. 1 magnesium and 1 magnesium. Are my atoms balanced with each other?
Yes.
Yeah. So for 14, my final answer is 2 AgNO3 plus MgCl2 yields, because I'm running out of space because I'm an idiot, didn't write wrote too big, 2 AgCl plus MgNO3 2. There's my final answer.
Oh, sure.
Yes.
So, number 5.
Number 5. We can do number 5. We got a little bit of time. All right. So, number 5. We got a request for number 5. This is the last one I'm going to do. We have ammonium nitrate, and it's breaking down to form dinitrogen monoxide and water. So, in this situation, I cannot count my polyatomic ions, even though I have 2. Why? Because they are not in my products. So I have to count each atom individually. How many atoms do I have? 1, 2, 3, or 4? 4? Nitrogen, oxygen, and what? Hydrogen. So I got 3 atoms I have to worry about, right? Nitrogen, hydrogen, oxygen. Now, excuse me. Which one do we want to start with? Do we want to start the nitrogen, the hydrogen, or the oxygen? Start with hydrogen? I like hydrogen. Sadiq, do you not like my choice? You want to do nitrogen? You know what? We're going to let the lady have the choice on this one. How many nitrogens do I count on my reactant side? 2. 1, 2. 2. And I got 2 on the other side. So that means that right now, my nitrogen looks balanced. I might have to come back to it because I only have 1 reactant and 2 products. Let's do the hydrogen next. I have 4 hydrogens on one side. And I have 2 on the other. How can I fix that?
Multiply by 2.
Multiply by 2. 2 times 4 hydrogens gives me 4 hydrogens. I have 3 oxygens on my reactant side. How many oxygens do I have on my product side?
1.
All right, I got an option for 1. I've heard 2, and I've heard 3. Let's count them together.
Oh,
I see 1 right here, right?
We got 2.
We got more than that. Plus 2 times 1 oxygen gives me how many oxygens?
so 3.
2. So I have a total of 1 plus 2, 3 oxygens.
Which is that 2 in front of the O and like is the 2 in front of the O a part of the oxygen?
No. So the 2 that's in front of this oxygen is the nitrogen. 2 nitrogen, dinitrogen monoxide. And then I have 2 hydrogens and 1 oxygen. Now this 2 is going to get distributed to the hydrogen and the oxygen, just like if it was in algebra and it was in parentheses. So that means I have 2 times 2 hydrogens gives me 4 hydrogens. 2 times 1 oxygen gives me 2 oxygen. But because I'm counting the atoms, I have to account for all the oxygen on my product side. That's why I added those 2 together. So we have to be careful with it. Well, let's see where we're at right now for time.
It's just a good question. I mean, like, whether I can do this or not.
Well, what I'll do is I'll check it out in a quick second. So give me 1 quick second. Let me get everyone started on the next thing. All right. So, ladies and gentlemen, I want to make sure we have enough time to do our experiment today. Now, what we're going to do today is that we are going to collect our data today because I want to do some more practice with our equations before I tell you to start balancing these equations. So, what I need everyone to do, you should have already picked up to precipitate lab already. Everyone's got this paper right here? Everybody's got this one? Alright. What I need from you to do that, I need you to get a pair of goggles. I need you to get an apron. And then I need you to find a friend. Not two friends, not three friends, a friend. Find a friend. Ferris, after you've gotten your goggles, your aprons, and you found your friend, you can hit the restroom, right? After him, absolutely. That's fine. No, I'm sorry. You're after him.
I found out, but it's because I was asking if we could have done like CO3 at first and CO2 as another one, but then I realized that there wasn't a CO2.
Yeah, and unfortunately, so those are, 5 and 6 are great examples of what's called decomposition reactions, where I have one reactant and I have multiple products, because something's breaking down. So when you start breaking down like that, we don't want to count the polyatomic ions by themselves, unless the breakdown is the polyatomic ions. Come on. So, just a reminder, I just want to put this out there. There was 14 questions. We've cut down 3 of those 14 questions. So that leaves you with 11. You are to finish the other 11.
Hey, give me a pair of goggles.
All right.